Hello everyone. Welcome to section 3 of Big Data Analytics using Apache Spark. At the end of this section, you'll be able to work with RDDs. Also, you will explore data frames and data sets. Finally, you'll be able to understand how to do data pre-processing. In a nutshell, this section is about writing Spark programs for big data processing. In this video of section 3, you will learn about RDDs. Resilient distributed data sets, which are called RDDs, are the primary abstraction of Apache Spark. They are a collection of elements. In fact, they are partitioned across the nodes of the cluster for parallel execution. In fact, the words resilient means fault tolerant, distributed means data across different nodes on a cluster, and data set means partition data. In this demo, let's understand on creating RDDs as well as their operations. In addition, we will see how to develop a Spark application using IntelliJ. Spark supports development with Java, Python as well as R. We will be using IntelliJ as our IDE, and since we are using Scala, we will be using SBT as our build manager. As you can see here, you have to install IntelliJ IDE, Scala plugin and SBT configuration file, which are available on these links. As you can see on the first link, which is the IntelliJ IDEA, you have two different versions, namely the Ultimate and Community Edition. So depending upon your operating system, it will automatically show the download page. In our case, you have to download the Community Edition. Next, you have to install the Scala plugin. As you can see here on this link, you will see how to install a Scala plugin. Next, we have to configure the SBT. As you can see here, this is the content of a typical SBT file. And as you can see here, Spark 2.31, we go with the 2.11 Scala version, and for different versions you can refer the Maven repository, and inside that Maven repository you can go to Apache Spark, and here if you click on Spark project core, you will end up on this page. In our case it's 2.3.1. Let's click on 2.3.1. As you can see here, it shows the Scala target as Scala 2.11, and you can also see the content which we have to include within our SBT configuration file, which is same as on the Apache Spark website. So as you can see here, this is a typical IntelliJ IDEA project, and here is the build.sbt file. If you want to, you can copy from the Apache Spark website and you can paste it. And as you can see, the program has three parts, namely, which is inside the main method. The first one is creating a Spark context, and next is creating an RDD, and third is RDD operations. So firstly, when you think of Spark context, we'll specify the Spark properties. In our case, we create an object called conf, and we set the URL as local of 2, which represents that we are running Spark on the local mode with 2 threads. Spark will not run distributed on this mode, right? And then next we are specifying the app name, and also we are creating a Spark context SC based on the Spark context constructor, and also conf is the object which contains information about this application. As the next step, we create an RDD. So you can create an RDD from a text file. So with the help of this text file method, the way we create is a c.text file, and we are specifying the file name. In our example, it's kjv.txt, which is an open source version of the Bible. So the objective of this project is to do text processing. For a given text document, we want to find out the occurrences of each word. In other words, we want to find out the word count. On the next step, we look at RDD operations. We have two RDD operations, actions and transformations. Actions are nothing but meant for returning values, and transformations are for returning a new RDDs sometimes. So in our case, we have three kinds of transformations. We have used three transformations, namely flat map, map, and reduce by key. So from the text file RDD, we are creating one more RDD by applying transformations. So we take every sentence of the document and then split the sentence by spaces. Once we do that, for every word, we give a count of 1, and then we find out the total number of occurrences for that particular word. And finally, we store the output of all these occurrences in a Word file using save as a text file method. Make sure that the output directory doesn't exist before. In our case, it's Word 5. If it exists, that means it will throw an error. So in this case, I'm renaming it as word count. I'm creating a new directory. So when you execute this program, it may take a couple of minutes depending upon the speed of your computer. If you get the exit code as 0, that means that the program has ran successfully. For instance, if you look at for the word silence, it shows that the word silence has occurred 13 times. You can also go to that particular folder. In our case, it's word count. We have 3 files. First is success, which denotes that the program has run successfully. And second is part with 6 zeros, which is the first of or the majority of the output. And the remaining part of the output will be on part 501 file.